Hey geometry team, welcome to Unit 8, Day 5, the last day in our unit for circles and segments and arcs. So let's get started. So to begin, we're going to be talking about the lengths of segments when they're intersecting inside circles, okay, or outside circles. So to start off, we'll start with the interior intersection. This is when you have two chords that cross in the center. And what's going to happen when they cross in the center is that you're going to make up two parts of one chord and two parts of the other chord. And the two parts of one of the chords will get multiplied together. The two parts of the other chord will get multiplied together. And crazily enough, those two products are always going to be equal because we're inside a circle. And so what's that going to look like? Well, I'm going to have that AO is this part of this chord. And then the other part is OD. And these two get multiplied together. All right? Then you look at your other chord. I'm going to take one of those parts, so CO, and multiply it times its other part inside the circle, which is going to be OB. And so I have this part times this part equals this one times that one. That's how we find pieces of chords when they intersect inside the circle. And then we can use those numbers to do all sorts of other fun things that you'll get to later. All the other pieces and problems that we're going to do are going to involve intersections that are outside the circle. And they're going to have a different kind of formula than we were inside. So you know this one, you love this one, but now the rest of these are going to involve a different formula. So for this one, you'll notice that we have an outside piece of each of these segments. I've got this outside part and this outside part. We only worry about the parts that go from the vertex intersection to the edge of the circle. Anything that hangs out the other side, we're not worried about. You can figure that out some other way, but all we can focus on is from this vertex intersection to the edge of the circle. And the way this works is that we're going to have, I forgot to tell you that these chords don't usually match up. They're not usually congruent, and so don't panic if they're not. Okay, so over here, what we're going to focus on is the length of this outside piece and the length of the whole segment from the intersection to the edge of the circle. We are not going to be using this inside part on its own, okay? And so be aware of that and watch what's going to happen. So I'm going to do outside times the whole length is supposed to equal the outside times my whole length. So what that's going to look like, the outside of this first guy is this length from E to B. And then this whole segment goes from E to A. Okay? And so I need how long this piece is, and I need how long that whole one is. Those are going to get multiplied together. Then we do the same thing for the other secant. And so I'm going to have the outside part from E to D multiplied by the whole segment from the vertex to the outside edge here, so from E to C. And that's how you find these parts. You plug whatever parts you have into this formula and use your algebra to solve for whatever you need to find, which we'll get to see in an example in a minute. So let's see what happens when we switch from both of them being secants down to being tangents and secants. And we'll start with two tangents first, might as well. It's the easier one. So if we have two tangents, notice something, that if you ignore this segment right here, I have an outside part for here and nothing else. The outside part is the whole thing. So when I go to do outside times the whole thing, my outside part is the whole thing. And so I'm going to end up doing outside times outside, which is going to give me, come on, there you go. It's going to give me the outside squared. And on this tangent, the outside is the whole thing. So I'm going to have outside squared here. So instead of doing outside times whole and outside times whole, I just do outside squared for this line. And it's going to equal the outside squared for this guy. Okay? Well, the outside times the outside here is AB squared. The outside times here is AC squared. Well, if I square root both sides of that, I just get that AB equals AC, which brings us to a fun fact about tangents. And that is when you have two tangents that intersect outside the circle, those two tangents are always congruent. So you don't even really need a formula for it. This is just how we know that they are is because the outside times the whole is just the outside squared and the outside squared being equal to each other. So yay, tangents are always equal, nothing to remember. Then you get a tangent and a secant intersecting outside your circle. And what's going to happen here is you're going to use this same formula again. So I need an outside piece times the whole, come here, where'd you go? So I need an outside piece times a whole thing for this segment, but since this one's a tangent, the outside and the whole are the same thing, so outside squared. And so let's see what that looks like. So the outside of this secant guy is going to be from D to A. And we're going to multiply that times the length of the whole segment, which is from D to B. All right, here. And that's going to equal whatever I get when I do the same thing down here. Well, here, my outside part is from D to C, and my whole thing is from D to C. So I do D to C times DC, which is DC squared. So these two pieces multiplied equals this times itself. Okay, so what does that look like when we're solving problems? Let's check it out. So for this first example, I've got this guy, kind of looks like one of those railroad crossing signs for those of you learning to drive. It looks kind of like this, all right? And so if you remember, our formula when our chords cross inside is that my parts times my part for one chord will equal the part times the part for the other chord. And so let's set up those parts and see what's going to happen. So I'm going to make my first one be this 14. And so the other part it'll get multiplied by is this other part of that chord. And so that's going to be 15. So it'll be 14 times 15 should equal my x times my 10. So let's set that up in here. So I've got my 14 times 15, this chord multiplied, equals x times 10, the parts of this chord multiplied. So I have part times part equals part times part. Algebra, 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 and you end up with x equaling 21. And yes, I know that this chord does not equal this chord, and that's fine. They aren't going to be equal unless they both are diameters, or like we learned in day 4, unless they're both equidistant from the center. We don't know that. We have nothing to indicate that, so it doesn't surprise us that these things are not congruent here. Okay? Moving along to a second example now. Come on, buddy. You can do it. There we are. So on this guy, I'm going to have a tangent and a secant. They intersect outside. And so this is where I know I'm going to use the one that says outside times the whole thing. And so, okay, I'm going to have outside times whole. But then I know that for the other one, since the outside is the whole thing, it'll be outside squared. So let's set up those parts. So the outside of this guy is going to be this blue part that's 9. And then I need to multiply it times the whole thing. But wait a minute. Record scratch, I don't know how long this whole thing is. You're immediately going to want to say 16. But it's not 16, okay? 16 is just this much. But I need the whole segment from the vertex to the other side of the circle. And so I'm going to have to figure out how much that is. Well, to get that, I'm going to add these two pieces. So 16 plus 9 will equal 25. And so when I'm ready to do my problem here, my outside, come here, is 9. My whole thing is 25. So outside times whole is going to be 9 times 25. And then this guy is 3x, and so he's going to get squared. So 3x is going to get squared. Then you get to do all the algebra. 3x squared, remember your exponent rules, is going to end up being 9x squared. And over here you get 225. So to get the x squared by itself, let's divide off the 9. And then we would square root both sides here so that those would cancel, and x would turn out to be 5. So x equals 5, which means that this segment, this tangent piece out here, was 15 total. But we didn't need to know that. All I needed was x, and here's x. But you could plug it in and find that tangent piece now because you know what it is. Okay, example 3. For example 3 here, I've got two secants intersecting outside the circle. And since they intersect outside, I know I'm going to use my formula that says outside times whole equals outside times whole. So let's pull that up so we can look at it. So I need to label an outside part, a whole piece, another outside part, and a whole piece. So let's see what we've got in here. So my outside part of this first guy is going to be this blue guy. He's 8. Okay? The whole thing is going to go from here to here. So I need to add up and find out how much that is. So the 8 plus the 19 is going to be 27. Then down here, I've got my outside part, which is 9. And then I need the whole thing, which is this green part. Well, again, I need to calculate how much that whole thing is. And to get it, I would take this 9 and I would add x to it. And I don't know how much that is, but I learned algebra. And so I can still play with the numbers without knowing what they are. So let's put that into our formula now. So I'm going to put my outside times my whole. So my 8 times my 27 is going to equal my outside, which is 9, times the green segment, which is 9 plus x, or x plus 9. Those are the same thing. And now I'm going to algebra. 18 times 27 is 216. I would distribute here to get 9x plus 81. Subtract from both sides, divide both sides by 9, and x comes out to be 15. So again, just be super careful to figure out how much this whole segment is before you plug it into your formula so you get the right answer. Wrong answers, not so much fun. Okay, erase some garbage out of here and get to our last example of the day. So for example 4, I have another tangent and another secant. And let's figure it out. So since I have an outside intersection, I'm going to use the formula that's going to say outside times whole equals outside times whole. And in this case, my outside times whole, well, the tangent, the outside, is the whole thing, so you get outside squared. Let's set up our parts. So I need my outside part of one of my segments first. So I'm going to use that one to be 18. Then I need a whole segment. So this whole segment is this red piece, and I need to calculate how much that is. Well, I know I get the red piece by doing this part plus the inside part. And so I know it's going to be 18 plus x, or x plus 18. You know what? We can leave it that way. And then my tangent is going to be 24, so that's the one that's going to get squared. Okay? So let's go put it in our formula now. So I have my outside part times my whole segment, so the 18 plus x, and that's going to equal the 24 from the tangent times itself. So you start working this out. So the 18 times 18 is 324. 18 times x is 18x. And I put this in my calculator and get this fella, 576. I'm going to work it out, subtract the 324, divide by the 18, and x comes out to be 14 right here. In your assignment, we're going to give you different things that involve where x is or adding things and stuff, and you'll still always just set it up into these same formulas to find the links of your segments. Thank you, geometry team, and we'll see you next time.